Hi guys, all of you good morning and good evening to all. Guys, welcome back to DevOps multi-cloud on-premise DevOps training with DevSecOps on multi-cloud with on-premise. Okay guys, and so a little bit we are going back what we have covered in previous classes. So far we have covered the Git core concepts like cloning, committing, pushing, branching, and merging. Okay, and like that stash. Okay, rebasing, pulling. We have discussed okay these concepts. However, still we are having some more few advanced concepts like that cherry pick, resolving complex Git merge conflicts, and Git tagging. Okay, and we are having some more Git logging related to branch commands. Okay, we are having some more advanced concepts. So I'll cover by making videos. Okay, I'll upload those videos also. You can go through that on your free time. Okay, so here we are having some more important concepts in DevOps. Okay, so we can't stay much more with these Git tools. We have covered whatever the important concepts in Git, but not only those concepts, still we are having some more concepts in Git also. Okay, I'll make those videos on those concepts. So meanwhile, we will start Jenkins. Jenkins also very, very important tool. Okay, so I have paused those Git concepts and we are going to focusing on Jenkins and understanding CI/CD workflows. Okay, since it directly connects with the version control. Okay, so once again, I am more confident with the Jenkins pipelines and the documentation. Okay, so we are going to working with Jenkins, guys. So what is a Jenkins? It's a very important concept, guys. Jenkins is the very, very important concept in real world CI/CD pipeline. Jenkins has an open source automation server with Java. It's written in Java. Jenkins is a automation server software and it's written in Java. It helps for automating parts of software development like building, testing, and deploying, enabling teams to implement continuous integration, that is CI, and one more is there continuous delivery. Okay, so originally it's developed by Tuski, Kawaguchi in 2011 as Hudson. Okay, guys. Jenkins is now one of the most popular tool in DevOps tool chains. Jenkins playing main key role in the most popular tools in DevOps tool chain. So the key concepts, whatever we are having in Jenkins, yes, the importance of Jenkins. By Jenkins, we can automate each and every concept for reducing human errors. We are going to we can eliminate manual steps for reducing human errors. And by using Jenkins, we can develop fastly, accurately, quickly, and we can enable quick feedback for debugging and fixing by integrating code frequently. By code integrating, we can fix quickly and easily. Transparently, we can maintain end-to-end process. So what is that Jenkins image? Yes, let me show you Jenkins. This is the Jenkins tool. Yes. This is the Jenkins tool. So what we can, yes, we can plan accordingly, and we can code, we can get into code from version control locations or servers, and we can build it, and we can test it, and we can release, and we can deploy, and we can operate, and we can monitor. Jenkins is the very powerful tool. It's playing main key role. So by using Jenkins, we can automate, and by using Jenkins, we can faster development, and we can use Jenkins for consistency, and we can do integration by using Jenkins. We can do scalability by using Jenkins. We can do open source and free of cost backend by strong community. Scalability supports distributed tools across multiple maintenance missions. Scalability, it supports us distributed tools across multiple missions. I mean that it's calling as a master slave. Yes, by using this Jenkins, we can integrate works with 1800 plus plugins for tools like Git, Docker, Maven, Gradle, AWS, Azure, Jenkins, like that, SonarQube, Nexus, Grafana, Prometheus, Nagios, okay, Kubernetes, okay, which are important in Jenkins. Not only DevOps tools, yes, like that Sharp, ABAP, not only one part, guys. Okay, who are using softwares in the industry, IT industry, mostly 70 to 80%, 80 to 90%, it's covering, or it is supporting to all these peoples. 1800 plus plugins we can use in the Jenkins. It is supporting. Okay, guys. Next, coming to consistency. So it ensures that uniform build, test, and deployment process across the entire environment. And yes, it gives us fast development, enables quick feedback, and bug fixings. Okay, debugging or bug fixings by integrating code frequently. Okay, next, automation. So we can eliminate manual steps for reducing errors, time waste. We can reduce time consumption, and we can reduce that communication gap in between the team members, and we can go for accurate process. Not only this, yes, some more advantages with Jenkins. So in upcoming classes, we will see practically what we can do by using Jenkins. Yes, how we can work with Jenkins in the real world. Yes, in real world, by using DevOps pipelines, Jenkins typically developer push the code developer push the code mean? Yes, guys. So as of so far, we have seen 1 minute. Okay, guys. So far, we have seen Linux and Git. Linux and Git we have seen. So how it works? Okay. So we have seen using Git commands and the Linux commands, but one more tool. Okay, we are introducing one more tool, that is Jenkins. So far, we have seen the developers are going to writing code, not only developers. Okay, you should not keep in mind like that. We are also one kind of developers. DevOps engineers also one kind of developers, developing automation scripts, configuration management scripts, for package management scripts, for networking management scripts, okay, for monitoring management scripts, for testing management scripts. Yes, not only programmer, I mean that not only Java developer, not only Python developer, not only C++ developers. So we are also developers to develop automation scripts like that. Jenkins pipelines we are going to developing, YAML files we are going to developing, and Docker files we are going to developing. Okay, and YAML files also for configuration and management we are developing. At the same time, the same YAML files we are going to developing for deployment and monitoring by using Kubernetes. Okay, we are using those YAML files. Okay, guys. So we are going to developing and we are going to centralizing like this. Like, see, guys, we are going to centralizing. What are these? See, these all are the scripts. These all are the scripts. So we are going to developing like that, and we are going to centralizing. We are going to centralizing. See, guys, for future reference, we are creating as a template. We are creating as a template, and we are going to write in pipeline scripts like that. Let me show you pipeline scripts. See, guys, Jenkins file, Docker file. See, guys. So we are going to writing and we are going to centralizing. See, this is a Docker file and a Jenkins file. See, we are going to writing like that pipeline scripts and placing here. From here, we are calling into Jenkins. This one is really we are going to writing this kind of scripts, and we are going to integrating with Jenkins, where we have developed in our local mission. We have developed and we have centralized in this GitHub repository. If you are the member, if I am the member in the same project, yes, if you are working on CI/CD pipeline, or if you are working as a DevOps engineer, automation engineer, configuration management engineer, yes, you can use this repository for your contribution. Okay, based on roles and responsibilities, we are going to develop in scripts and we are uploading into this GitHub repository. From here, we are going to integrating this repository into Jenkins. From there, we are accessing different activities. So here, as of now, so far we have seen developers. I mean that, of course, we have developed. Myself only I have developed some scripts for installing Git, and something we have written and I shown you that. I think as per your experience, you have seen only one, how we can install Git by using shell script. I think in the day 1 and the day 2 classes I have shown you. Okay. Yes, you can go through that, and once again you can check that video maybe in the second video or third video. Okay. So we are going to recapping. Of course, I'm not going to recapping. I'm using Git. I'm using Git for integrating Jenkins. Whatever we learned so far, those tools we are not missing. Those are traveling. We are traveling with those tools. We have to travel with those tools until unless finishing that DevOps environment end to end. 100%. We have to travel with those tools like that Linux and Git. And today we have started to travel with Jenkins. This is the third tool. This is the third tool in our DevOps journey. Yes, in upcoming days, when we are going forward day to day, yes, some more tools join with us, or else we are joining with those tools. Because it's a journey. It's a journey. Okay, maybe we are at a third milestone. Okay, guys. So now we need to integrate. We need to discuss what is a Linux, what is a Git, and what is Jenkins. How we can work with these three tools by combining. What is the part of Jenkins? What is the part of Linux? And what is the part of Git? What is our responsibility to work with these three tools? We need to learn this. Okay, let me show you that. See, guys, as a system engineer, DevOps engineer, and developer. I mean that a developer means source code developer by using Python or Python by using what is that? C++. Okay, yes. Java engineer, Java developer. Okay, like that. So many. Not only this. Okay, network engineer, system engineer. Like that, we are having different users in the team, different team members in the project. Just I have taken two examples in this case. See, guys, as a DevOps engineer, as a developer, as a system engineer, as a network engineer, as a database engineer, as a test engineer. So these all our guys are using Git to develop and integrating with real world project. Okay, they are going to developing and they are going to contributing their contribution into one source code location, centralized location, that is calling as a SCM. That is calling as a SCM, source code management repository, centralized source code management, SCM. Guys, keep in mind, sometimes maybe you'll be in confusion. Maybe you will be in confusion. What is the confusion here? Some guys will ask you a question. What is SCM? What is SCM? SCM nothing but source code management repository or source code management. In one way, SCM means source code management. In another way, software configuration management. Keep in mind, in another way, we can call as a software configuration management. If you confuse, if you are having confused, yes, you can ask them. You mean source code management or software configuration management? Okay, yes, which one you are asking? So if you are related to, if your question related to software configuration management, yes, that one we can use. Those are the tools like that Chef, Ansible, Puppet, SaltStack, like that. So many tools are there for configuration environment. End to end, we can configure and manage environment. I mean that, yes, for creating users, denying the permissions to users, and installing the packages, uninstalling the packages, and give, okay, like that we can do getting the logs, we can do whatever we want. We can manage end to end, and we can control the missions end to end by using this software configuration management tools. Software configuration management tools. Coming to source code management, yes, we can centralize the code in one location. From there, we can integrate the code, or we can integrate those repository to CI/CD pipeline tools. CI/CD pipeline tools. Source code management tool, it is a tool. Every developer, they are contributing their contribution into source code management repositories. It's a centralized server. We can store the data. I mean that we can store the all kinds of files in the centralized server. This is the concept. Okay, if you have some more stuff, yes, you can go through that. Okay, so until when he saying that okay or something, okay, you should not stop about it. Okay, guys. Next, coming to, so whatever we did the changes, on our day-to-day tasks. After that, we are going to centralizing the code in the GitHub repository. After that, we didn't do anything. After centralizing the code, whatever we did the changes, we have uploaded or we sent to remote repository. After that, after sending to remote, we didn't do anything. From today, we are going to integrating with Jenkins. Whatever we have sent to remote repository, we are taking the code and sending to CI/CD pipeline tool. Continuous integration and continuous delivery and continuous deployment. Not only Jenkins tool, not only Jenkins CI/CD tool, there are so many tools. Bitbucket is there, GitLab is there, TeamCity is there, and Hudson is there. Okay, so many tools are there. And GitHub Actions also there. Amazon, AWS, CI/CD pipeline also there. So many tools are there in the market. However, Jenkins playing main key role this entire environment in the real world. And it's a leading software in the market, but it's a open source. Tool. But it's playing main key role in the industry. It's a leading software also. So that we are using this Jenkins tool for our DevOps flow. Okay, guys. Now, so far we did, guys. We have centralized the code in the source code. Which one? We are using Git SCM tool. GitHub SCM tool. We have used this one, guys. So here what we are doing, we are going to creating repositories like this. See, guys, here I have that nearly 63 around repositories. One repository is nothing but one project. Okay, guys. So yes, and this is my overall experience. on this GitHub account, and I have that two more. Old one. Yes, I have started almost in 2015 and 2016. Okay. So I have started working with this GitHub account in 2015. See, guys. You have to maintain your own GitHub repositories for your job referrals. Okay, guys. That is very helpful to you. Yes, you can express your ideas, your experience, and whatever you did in your real world, in real time, is those by using those experience, you can develop the scripts and you can upload here. You can upload here. So if anyone asks the question, yes, you can say this. You can say this. For example, if anyone asks me that, yes, if I say this one, yes, he can get one idea. Yes, this guy using from 2017 this GitHub. So it's me. He's having almost 8 years of experience. 8 years of experience. If I say that to my two more, that when I have started with working with 2015 GitHub, so mostly 10 years of experience. 10 years of experience. See guys, indirectly or directly you are saying that yes, this is my experience with working with Git and GitHub. They can understand. They can understand. Okay guys. So try to manage your own GitHub repositories, GitHub account. Okay, frequently try to do something and upload in your repositories. Okay guys. So now guys, so here, so these all are the repositories. These all are the repositories. See guys. And it tells us what you have uploaded, what you have placed inside that repository. Is it a CSS or is it HTML or JavaScript or Java or .NET or whatever. See guys. Yes, like that. Okay, it tells us. These all are the repositories. These all are the repositories. In real world also. In real world also. Yes, in the GitHub repository, we are having multiple repositories. We are having multiple repositories, or else we are going to working with multiple repositories. But as of now, we are having one repository, that is one XYZ project. XYZ project. This is the project. Okay. Yes, we are uploading the code into this repository. Now the team working with this repository. Okay, guys. We are working with this repository, guys. Now, just now we have uploaded the code inside this repository, in the XYZ repository. So from there we need to integrate this code into Jenkins. So why we need to integrate? Yes, from here, once you integrate the code from GitHub to Jenkins, yes, we need to check the code quality. Code quality means code analysis. Okay. Code quality analysis. Already code developed. Before building, we need to check the code quality. Why we need to check code quality? Yes, here the important. Okay, developers push the code to source code control system, like that example already, which we are going to use in GitHub. And Jenkins detects the changes by using webhooks or polling. Then we are sending to the build location. For compiling the code by using Maven or Ant or Gradle. Okay, like there so many tools are there. While compiling the code, we will get the errors. If any error is there, yes, it will send back to developer. Okay. Before that, if there are no errors, Okay, if there are no errors, but with that code, we will get some issues with that code. If we continue with the code for building, after building, yes, we got one artifact. Yes, we have tested that artifact successfully, and we are deploying to the production environment. Once we deploy that product in the environment, yes, we'll get some issues. Yes, it's causing for server shutdowning or server falling. It's consuming huge RAM or disk space or network consume or processor consume by deploying that application. When the application is consuming huge resources, slowly the server will go down. Finally, it will crash or it will shut down. If it is server shutdowning, yes, we are breaking our promise. We are breaking our promise. What is our promise? Yes, our vendor has given promise. Our vendor has given promise to client. Yes, we will provide zero downtime service on your business. Zero downtime mean the server should not stop on any condition, on any time. We should run the server 24/7, 365 days, 30 days and 365 days. That is the promise. Our vendor has given promise to his client. As per our vendor promise, we need to work on that. We need to work on that condition or promise. Here, vendor is the helpless. The employees are playing main key role. If the system engineer is not concentrating on server health, he is the responsible. He is the responsible here. Now the server is going down due to deploying that application, which one the developer developed the code. In the quality location, it is certified. In the compilation location, it is certified, it's compiled successfully. In the test area also, yes, tested successfully. But once we deploy that application in the environment, yes, the servers are going down due to consuming huge resources. Finally, in any 1 minute or any 1 hour or in 1 day, yes, server crashing. When the server is crashing, the remaining guys are not responsible. Plan engineer is not responsible. Source code developer is not responsible. Build engineer is not responsible. Test engineer is not responsible. Release manager is not responsible. Deploymenter is not responsible. Yes, monitor engineer is not responsible. Operations team. Even in the operations team, yes, system engineer is also there. System engineers mean system administrators. They are the responsible here. Before deploying that application, yes, server was working clearly and calmly with a healthy. Once we deploy that, yes, all of a sudden it started the server falling. Now you tell me, maybe there is the compatibility issues in between that application and the server. Maybe some compatibility issues. These both guys, system engineer and developer, they have to sit together and they have to concentrate what kind of servers, sir, what kind of services you are using, what kind of softwares you are using, what are the compatibility issues, is there any compatible issue, what are the compatible softwares for that OS operating system. Based on operating system, these guys have to use softwares versions also. They have to sit together and they have to design one documentation as per client requirement. Yes, once again they have to start. Coordination. coordination. DevOps is not a tool. DevOps is not a tool. And DevOps is not a only automation. It's a collaboration. It's a coordination. It's a set of tools. See guys, okay? So here, code quality is very important. Why code quality is very important? See here, I'm writing one program. Here I'm writing one program. Yes, let me show you. Yes, here I'm writing that class sum. Yes, public static void main string of args. Yes, next int a comma b comma c. Okay, a equals to b equals to, okay, c equals to a plus b plus c. Next, system dot out dot print ln the sum of three values are, yes, plus c. Okay guys, plus c. Okay, now close this program. This is one program. This is one program. If you send this one, for code quality location, 100%, this program will reject. This program rejecting by the code quality analysis tool. Code quality analysis tool. So yes, the same program, class sum are mandatory, public static void main string of args. Yes, int a equals to 50, b equals to 220. Yes, c equals to 450. Okay, next, system dot out dot print ln the sum of values are, yes, plus what is that? C. If you print that values, what we will get, guys? Sorry, we need to apply that now. C equals to C plus A plus B plus C. Okay, guys. Now you tell me which one is the easiest one. Guys, open up your mouth. Which one is the easiest one? Yes, guys. Which one is the easiest one in these two programs? Guys, are you audible me? Both are same. Both programs are same. But which one is the easiest one to run that application? Which one is the easiest one to server? Guys, are you there, guys? Are you understanding or not? Guys, I'm talking to you guys. Please respond. Hello? Guys, are you audible me? Guys, are you audible me?
Yes, sir, audible.
What happened, man? It's not a one-sided class. Try to respond. At least. Okay? See, guys. Now the second one is the simple and easiest. And in the second program, there are no repetitions. There are no repetitions. That is the one advantage. When you are going to using that, or when you are going to repeating the same values again and again, yes, the code quality tool immediately it will reject that. Why you are going to repeating again and again? Due to that, yes, system will consume huge disk space, and system will consume huge processor, and system will consume huge RAM, and system will consume huge networking. By consuming this, automatically the system performance will go down. But there is no any error logically. There is no error. Of course, we can rectify. If have any error, maybe those are very, very small. Yes, we can rectify. If you send these two programs to code quality analysis tool, immediately the code quality analysis tool immediately it will reject the first program. This one it will reject, because see here we have repeated again and again. A repeated once again. But here very simple, very easy, lightweight, same output. So here one more, that if we send to Python, see here A equals to same values. Okay, same values compared to Java and Python. See guys, now just print. If you want to write something here, you can write, or else just apply that. This one. See guys, in Python, it's very simple. It will display the output. What is the value? What is the one? Yes, 670 plus 50. 670 plus 50, 720. The output will come. 720. See, the same program. Okay. This is the Python program. This one, Python program. And this one Java, See, it's a heavyweight and a little bit lightweight, and this is some more little bit lightweight. See, here we need to write end to end the classes and methods and all. Okay, and internally the Python it will take that responsibility on classes and methods. Here you need to specify particular data type here. So when we are going to write in Python, if it is integer, if you have given that integer value, automatically it will recognize, yes, developer has given, yes, integer value. Yes, if it is like that, D, yes, 450 point something. Now it is a floating value. Automatically, yes, system can understand, yes, this is the floating value, this is the integer value, it is a double, or it is short, or it is a character, or it is a string, or it is Boolean. Automatically it can recognize. But here in Java and C++, you need to specify integer data type, or float data type, or string, or character, or double, or short. Without specifying that, it can't recognize, or it can't read the value. But coming to Python, yes, itself it recognizes. So that Python is very easy and very lightweight, and easy to learn also, compared to that Java and C++. And here also some guys are saying that Java is a robust programming. No. Okay, I'm not agreeing with that. Even Python also robust programming language. But the Python programming language, it will take internally the responsibility. Even in Python also without data type we can't. But internally they have developed some internal APIs. Automatically it can understand. Depends on what we have given the values. Okay, guys. So we need to check this code quality by using code analysis tool. Code analysis tool. We are using SonarQube. SonarQube. SonarQube is the code quality and code analysis tool for code quality checking. Code quality checking. So if you are using Java programming, yes, you can use. You can use, and we can use. You can use for .NET also. All kinds of programming language it will support. Next, coming to build. If the code quality is okay, after testing by code analysis tool, then it comes to build. Then it comes to build. By this build, what we are doing? Yes, we are converting source code into executable format. Source code into executable format, or end user application, or application software, or runnable application, or runnable software. As per client requirement, developers have developed the source code. After that, we are converting into executable package, runnable package. Maybe the package is .exe, .msi, .jar, .var, .er, .dll, .rpm, .db. Okay, depends on operating system compatibility. We are going to developing those packages. Finally, the expression is, the output is same. If you are running that application on Windows, as per user requirement, we have developed the application for Windows, or the same application we have developed for Linux. When you run that application on Windows, yes, we need to get same output with comparing Linux operating system application. When you are going to running the application on Linux machine, or Mac, or Ubuntu, or Debian, or SUSE, yes, the same output want to come on all operating systems. But here compatibility issue, we need to convert, depends on that operating system. Finally, output is same. We need to develop that kind of application as per user requirement. So here we are using to build that application, yes, Ant, or Maven, or Gradle. We are using Gradle. Okay, guys. We are using Gradle. That application building. Once the code quality is okay. See, guys, by using Jenkins. Once a code build, once we develop the application, we are sending to artifact repository management tool. Here that is not available. Yes, one more will come here. Yes, we are using Nexus repository or JFrog. We are using Nexus repository management tool, or JFrog we can use, and we can use GitLab also. We can use GitLab also for storing artifact. Okay, guys. But mostly are using JFrog and Nexus. The first one occupied, okay, more sharing in the market. Second one, JFrog also occupied. Okay, percentage of the guys are using Nexus repository management tool. It is also open source. Ant also open source. Maven also open source. Gradle also open source. SonarQube also open source. See, guys, we can use. Okay. So once it's over, from there we are sending to test servers. Okay, either dev or QA or free staging or production. First, we need to send the product to test location. If everything is okay, then we are sending to UAT, user acceptance test. Okay, we are sending to test environment. Yes, once we get test clarification, test success, then we are writing pipeline script for releasing the application. For releasing the application, we are writing some scripts to release the product. The release engineer, the release manager will release the application. So once we got the release approvals, from the release manager, then we are going to deploying the application in the production environment. Okay, see guys, we are doing by using Jenkins. That's why we are saying that Jenkins is a very powerful tool. Then we are deploying into production environment. So once we deploy the application in production environment, now the process started to operate that product. So once we deploy in the production environment, yes, from there, all kinds of engineers have to start working on that production environment servers for securing and protecting that application. The client application we have deployed into production environment. From there, we need to give the assurance to client. Yes, we will maintain this server with 0 downtime. The server should not be stopped by any reason or any cause. That is the responsibility of the entire team. The operation team means, yes, system engineers are there, hardware engineers are there, and network engineers are there, application engineers are there, a database team is there. Okay, and that application server engineers, middleware applications, WebSphere or JBoss or Glassfish, Tomcat, IIS. Okay, these all are the application servers. Once they deploy the application in that application server, from there they have to start work with the servers 24/7, 365 days without downtime. Okay, guys, they have to give assurance. Yes, we will maintain 0 downtime. If the server will crash or down, yes, the client will lose his business. So that every client, yes, looks at that kind of service. Yes, if the server is going down frequently, yes, there are some agreements, SLA, they have to follow that SLA agreements. Okay, guys, that's very important. We will discuss what is that SLA. Okay, how the project will work, when the project will start. So what kind of agreements are there, we will discuss in upcoming classes, guys. Okay, see guys. So once we deploy the application in environment, then the monitoring team, the operation team, they have to work on that production environment. So yes, once again, the separate team is there, monitoring team. The monitoring team will monitor always server health issue. Okay, server health. So who will follow this one? The monitoring team will follow that. Okay, here there are some separate servers are there, software servers are there, software applications are there. We need to configure and we need to integrate those all servers, whatever the servers are in the environment from beginning. Jenkins CI/CD servers, Jenkins master slaves, and Maven servers, Nexus servers, SonarQube server, and the tester servers, DB servers, networking servers, load balancers, each and every server we are integrating with this monitoring tool. The monitoring tool for using for to monitor the all servers health issue. Which server is healthy, which server is not healthy. If the server is not healthy, what is the reason for not healthy? Yes, is that server is consuming disk space or RAM or processor or network. Yes, we will configure thresholds. We will configure thresholds inside that monitoring server. There are different tools are there. In AWS CloudWatch is there, and we can configure open source Nagios also we can configure, and we can configure Grafana and Prometheus, and we can configure ELK, and we can configure Slack also for communication channel purpose. And Datadog is there. So many tools are there. So many tools are there for monitoring server's health issue and server's health application health. Okay, guys. Here we are using Grafana and Prometheus, and we will try to work with ELK also. Okay, so this is the flow, guys. But where you are using this one? Where you are using this one? Yes, on-premise or on cloud? On-premise or on cloud, or else are using both in hybrid mode. Hybrid mean on-premise plus on cloud. On-premise mean, sorry, hybrid mean on-premise plus on cloud. That's calling as a hybrid. And some money, what is that money guys who are having that huge money? Yes, they want to run application on multi-cloud. Simultaneously or parallelly, they will run their application in multi-cloud. For example, they are running application on AWS server. At the same time, they can use Azure or Google Cloud or any Oracle Cloud or any other cloud. At the same time, they will run their application on-premise also. For securing the application with zero downtime. Okay, guys. So Jenkins is playing main key role in the environment. So here, how it works: developer pushes the code, Jenkins detects the changes, builds the projects, runs the automated tests, generates reports, and deploys to staging and notifies the team. Developer pushes the code to source code control system like that GitHub or GitLab or Bitbucket or SVN, RTC, Firefox like that. But in our case, we are using GitHub. And Jenkins detects the changes. When we are going to configure webhooks in between this GitHub repository and Jenkins, when the GitHub repository will get new changes, automatically the GitHub sent to Jenkins. Or else when we are going to configuring periodical build, poll ACM, yes, automatically it will detect the changes for every 1 minute or 1 hour or 1 day, depends on given our scheduling time. Yes, it will go to CI/CD, I mean that GitHub repository. Yes, Jenkins will find the new changes. If the new changes are there, it will get from GitHub to its location. Then it will send to whatever we have configured the pipeline. We have configured pipeline and builds projects. Yes, it will compile by integrating the tools. Jenkins is it's a guys like our nervous system. It is not having any kind of its own own decisions. Jenkins not having its own decisions. It can't take own decisions. As a DevOps engineer, we need to configure and integrate the plugins, one tool to another tool. When we have configured pipeline, based on that pipeline, Jenkins act on those tasks. For example, if you have installed plugin, SonarQube plugin, code quality, yes, if you integrate this SonarQube to Jenkins, yes, it will do that work. Without doing this, Jenkins itself, it can't send to SonarQube. Okay, guys, like that. So yes, when we are going to integration these kind of activities, for compiling the code by using Maven or Gradle or any other Ant or MS build or something. Yes, depends on based on code, it will build that. It will build the code. And once we integrate that, once we install the plugins in the Jenkins, then once we integrate to Nexus server, yes, once the build is over by pipeline, depends on the pipeline format, then it goes to that artifact in Nexus server. Like that. Yes, what is the Jenkins pipeline? Yes, let me show you. Let me show you. See guys, this is one pipeline script. This is one pipeline script. See guys, this is also one pipeline. These are simple. Okay, we need to add some more here. So here we are having very simple one. Very simple one. So here there is no, yes, build is there. Docker build, not that. Okay, sorry. So I think here we saw that now. Let me show you. So here we saw that Jenkins file. See guys. Okay. So here we are having somewhat. Here we are having somewhat. See guys. First one in the pipeline, we are adding the tools. We are adding the tools and we are configuring environments and clean upping the workspace, whatever which one is existed one. Now we are pulling the code from GitHub to Jenkins. Then we are sending to code analysis. Then we are configuring code quality gates. Yes, we are restricting number of errors. If there are 2 bugs, yes, we are stopping. If there are more than 2 bugs, yes, we can pass that. We can pass. Like that, we can integrate code to SonarQube for code quality gates, and it will wait and it will check the code. See guys. Okay. Then we are going to installing dependencies, npm node package management. Node package management. We are installing that. Yes, we are checking that once again. We are checking that dependencies which are important, which are required for. Okay, that is the code scanning. I mean that scanning that. Okay, DevSecOps. For DevSecOps, we are using this OWASP and Trivi. Okay, we are using for code. Okay, dependency checking, guys. It will check that dependencies. Okay, see, and it will maintain that report. It will maintain that report. Next, Trivi also. Next, see, Docker we are using. And once again, we are using Trivi. And here we are having some more. We need to configure. Here there is no Nexus repository. There is no Nexus repository. We need to involve it. And creating image, scanning the image. Here we are building the image and tagging that image. Here tagging, and once again it's scanning and it's creating container. Then we need to deploy that image in the Docker Hub. After that, once again we need to pull that image for in the Kubernetes deployment. We need to write YAML files. We need to write YAML files, and we need to expand this pipeline script to deploy in the Kubernetes environment. So when we can do this all, yes, you must have knowledge and experience working with these all tools. You must have experience working with these tools. Otherwise, you can't. You can't. See, in this pipeline script, almost all tools are involved. All tools are involved end to end. But here I didn't write that. We need to write that Kubernetes script also, and we need to write Grafana Prometheus script also, and we need to write one more that, okay, some more related Kubernetes. Okay, guys, Helm chart. So we need to write that. So many tools also, steps are there. We need to be written like that. This is the pipeline script, one to beginning to ending. But now we are in Jenkins. Now we are in Jenkins. First, we need to configure Jenkins. We need to configure Jenkins. Then we need to integrate this one. We need to install and configure SonarQube. Then we need to send the code. Before that, what are the roles and responsibilities? What are the tasks? or inside what we can do by using Jenkins. What kind of tasks we can do? There are huge concepts in Jenkins. First, we need to learn user management, build management, and what is that? Configuring jobs. While configuring jobs, how we can build? Is it periodical build or manual build or webhooks build or pipeline build or pool SCM? And how we can take backup? What we have to do take backup? How we can create users? How we can deny the permissions? How we can configure restricting the jobs to Jenkins users? Okay, guys. These are the concepts. Maybe we can stay 1 week here. We are working with Jenkins for 1 week. Then we are not stopping Jenkins. After that, we are working with Jenkins and other tools. Jenkins with other tools. Okay, guys. So we need to start Jenkins. How we can integrate, how we can configure. First, we need to configure Jenkins on different environments, on-premise or on cloud, on containerization. Okay, guys, we can. So next, builds the projects by using compile, using Maven and Gradle, and one more that runs that unit test, integration test, and UA test. We can test the codes by using Selenium. Also, we can integrate. Next, one more generates reports, test results, code coverage, etc. So many we can integrate by installing plugins. And for deploying that in the production environment, by using Docker, Kubernetes, or cloud services, we can deploy the application in the production environment by using this Jenkins. Okay, guys. And we can get the notifications. We can get the notifications via email or Slack by configuring plugins, installing and configuring plugins in the Jenkins. Okay, guys. These are the little bit services. Then we are not only this, we are having some more. Taking the backups and all, and keep concepts in Jenkins, CI/CD tool, plugin ecosystem, automated testing, and web-based UI. Okay, scriptable pipelines, supports all text stacks, distributed builds, notifications and feedbacks. Yes, this all DevOps guys must have these all features. Essential for Agile, DevOps, and microservices setups. Okay, guys. By using Jenkins, we can set up DevOps environment for essential Agile, DevOps, and microservices setup. Okay, this is what we can do by using Jenkins, guys. Okay, it's a very powerful tool, very important, and very easy. Very easy also you can. But initially maybe little bit confusion. I think you can understand easily. I'll try as much as easy understanding, guys. Okay. Yes. If you have any doubt, you can ask me here. If you have any doubt, you can ask me here. From tomorrow, we are continuing with Jenkins, guys. From tomorrow, we are continuing with Jenkins. Okay, starting and installing, configuring Jenkins on premise. At the same time, guys, yes, you must, better to have that what is that AWS account, guys. You got it on my point? You must have AWS account, guys. If you have that AWS account, we can configure on AWS, and at the same time we can configure on premise. So first of all, let me show you on premise, then we will go for cloud. In cloud also, directly we can use console, and we can use by using Terraform also. By using Terraform also, we can configure this infrastructure. I mean that environment. Okay. by using infrastructure as a code, IAC. Terraform is the IAC tool, infrastructure as a code. Okay, guys, we can write scripting, Terraform scripts, just we can automate easily and simply. Okay, this is what we have discussed in today's session. If you have any doubt, you can ask me. From tomorrow, we are starting practically configuring Jenkins and integrating Jenkins, guys.